curious to understand how that analogy breaks down.
I think I'm hesitant to say that in-context learning is not doing gradient descent because, it's not doing explicit gradient descent, but I still think that, so in-context learning, basically, it's pattern completion within a token window, right? And it just turns out that there's a huge amount of patterns on the internet. And so you're right, the model kind of like learns to complete the pattern.
Yeah.
And that's inside the weights. The weights of the neural network are trying to discover patterns and complete the pattern. And there's some kind of an adaptation that happens inside the neural network, right? Which is kind of magical and just falls out from internet just because there's a lot of patterns. I will say that there have been some papers that I thought were interesting that actually look at the mechanisms behind in-context learning. And I do think it's possible that in-context learning actually runs a small gradient descent loop internally in the layers of the neural network. And so I recall one paper in particular where they were doing linear regression actually using in-context learning. So basically your inputs into the neural network are XY pairs, XY, XY, XY that happen to be on the line.
Yeah.
And then you do X and you expect the Y.
Yeah.
And the neural network, when you train it in this way, actually does do linear regression. And normally when you would run linear regression, you have a small gradient descent optimizer that basically looks at XY, looks at an error, calculates the gradient of the weights, and does the update a few times. It just turns out that when they looked at the weights of that in-context learning algorithm, they actually found some analogies to gradient descent mechanics. In fact, I think even the paper was stronger because they actually hard-coded the weights of a neural network to do gradient descent through attention and all the internals of the neural network. So I guess that's just my only pushback is that who knows how in-context learning works, but I actually think that it's probably doing a little bit of some kind of funky gradient descent internally, and that I think that that's possible. So I guess I was only pushing back on you're saying it's not doing in-context learning. Who knows what it's doing, but it's probably maybe doing something similar to it, but we don't know.
So then it's worth thinking about, okay, if both of them are implementing if in-context learning and pre-training are both implementing something like gradient descent,
right,
why does it feel like in-context learning actually we're getting to this like continual learning, real intelligence like thing, whereas you don't get the analogous feeling just from pre-training? At least you could argue that. And so if it's the same algorithm, what could be different? Well, one way you can think about it is how much information does the model store per information it receives from training? And if you look at pre-training, if you look at Llama 3, for example, I think it's trained on 15 trillion tokens. And if you look at the 70B model, that would be the equivalent of 0.07 bits per token in that it sees in pre-training in terms of like the information in the weights of the model compared to the tokens it reads. Whereas if you look at the KV cache and how it grows per additional token in context learning, it's like 320 kilobytes.
Yeah.
So that's a 35 millionfold difference in how much information per token is assimilated by the model.
Yeah.
I wonder if that's relevant at all.
I think I kind of agree. I mean, the way I usually put this is that anything that happens during the training of the neural network, the knowledge is only kind of like a hazy recollection of what happened in the training time. And that's because the compression is dramatic. You're taking 15 trillion tokens and you're compressing it to just your fine neural network of a few billion parameters. So obviously it's a massive amount of compression going on. So I kind of refer to it as like a hazy recollection of the internet documents, whereas anything that happens in the context window of the neural network, you're plugging all the tokens and it's building up all this KV cache representation, is very directly accessible to the neural net. So I compare the KV cache and the stuff that happens at test time to like more like a working memory. Like all the stuff that's in the context window is very directly accessible to the neural net. So there's always like these almost surprising analogies between LLMs and humans, and I find them kind of surprising because